Okay. 1 second, guys. Utter AI. Utter AI. 1 second, guys. Okay. Today I'm gonna be firm. You know, it has nothing to do with quantum physics. Um, or but it does with the non-lunar. It has nothing to do with quantum physics. I'm not doing quantum physics. It's a simple problem. But this has to be formalized. It's not a simple problem. Obviously, it's not a simple problem. Hey, walk. Hey, walk. Anyway, someone outside is pissing me off. Someone outside is pissing me off, fam. So, basically, what's the problem? The problem is this. So, this is basically on interdimensional. So because we like basically in physics we have in physics we have sharing, or we have interactions. In physics we have interactions. What do you mean by interactions? We share interactions. So in physics we share interactions. Interaction, like something, a pendulum swings from transfers energy, kinetic energy, from one. If you have a pendulum of a pendulum of Newton's cradle, and you have five pendulums, Newton's cradle transfers energy from one pendulum to the other, but that also comes to rest. It always comes to rest because it doesn't last forever. The same. What I'm trying to prove here is the same principle is true. The same principle holds true for all realities, for any reality. So you have division reality. You have non-local. The term non-local maximum, maximum, local maximum, local minimum, and non-local minimum. So you have four realities. This is the four-dimensional realities. Four quantities or realities. So I'm trying to prove for whether there's no gravity, there's no friction, but once you start an interaction in a reality, that interaction has to come to a stop. It has to come to a stop. So if I have if I have five pendulums, four fingers, five fingers here, five pendulums, and you have one hit the other, one bounce off the other, boom, boom, like Newton's cradle, the cradle of the pendulums interacting with each other, without any kind of physical laws defined, you have physical interaction, and it will stop. It will stop eventually. So the problem is it's a reality problem. So it's a realities problem. Why would it stop when there's no motion? Why would it stop? Let me give you the idea. Let me give you the whole rundown. So let me get Kimi up. Kimi asked me a great question. Uh, I'm not making this up. This is a fabric of reality. So we have to do this properly. So my core claim is the evidence I'll give today is something I will derive, but there's no isomorphic problem of locality, non-locality and locality. Where's Kimi when you need them? When you need Kimi, you can't find my Kimi application. Yeah, that's Kimi. So so the problem I'll derive now, I'll just person Kimi because I'm. So let me ask Kimi asking questions. So this is the problem I defined. I'll show you how it works now. Okay. Reality works because it shares interactions. If the interaction cannot be shared anymore, it will dissipate, you know. But something that will cause it to stop, because non-local reaction becomes, you know, things that are non-local, or global can now be, yeah. Let me remember. So let me look for my notes. So I'm gonna start with the idea. So if it so basically come to you got the formulas force net force equals zero. Net force equals zero. That's the first Newton's laws of motions. Force equals mass acceleration, and net negative force equals force. For every force is a negative force. Now, for every negative force is a force. So let's continue. So if you have a quantity, basically we're gonna derive from both systems in terms of physics laws and physical laws, and how to solve the solution in calculus too. So uh, interaction is geospatial. Remember that number. You need the sound output, so interaction is geospatial. So we're gonna derive both systems of basically we're gonna create using calculus two. Calculus 2, which is my understanding of, well, I know calculus 1, not even better than calculus 2. Using calculus 1, we're gonna try to explore how to parameter. We're gonna parameterize. We're gonna start. I'm gonna start to work this out, but I made mistakes, because this is new to me. So, without any external theories, because I'm gonna give you introduction to M theory, or new theories, as you go along. So you're gonna have net force equals zero. That means object at rest stays at rest. Force equals mass acceleration. The mass acting on direction of speed, the constant change of acceleration is equals to the mass of the mass of the pendulum, the ball of the pendulum inertia, well, uh, am I right? Inertia. Yeah, and negative force equals force. So we're gonna basically it's solving a system of linear equations. Solving so to define reality, so reality solves the following equation. So you have reality, they have non-linear, non-polar. Because if you're using a polar system, you have to have a non-polar reality. If you're using a non-linear system, using a non, if you're using a linear system, if it's a linear system of if it's a linear system, it's working on a non-linear. If it's a linear system of reality, it's working on a non-linear. If it's basically, if the reality is linear, it's working on a non-linear system, a non-linear reality. If it's polar system, it's working on a non-polar reality. You get the idea. So the idea is you have non-local, you have four realities. You have local, non-local, uh, and you have minimum and maximum, minimum and maximum. And these are terminologies of the realities. So if you have a function, so I'm gonna read this out. So basically, there's no problem that says if you have it has something to do with quantum physics. If you have a ball on an apex, a tennis ball on an apex, it will soon, at one point in time, slide down that hill, slope. It will slide. This is a realities problem. This is a valid mathematics, but that is the same problem as a pendulum. So if you have something at rest, an object at rest, and that object at rest is a tennis ball, and it's an apex, it will soon slide down that reality. It will slide down that reality because sliding on slope because reality is shared. It's a fabric. It has to. It just takes enough time. If the ball was placed still there, if the ball was placed there, if the ball was placed there, you know, it will slide down the slide on a slope from the apex. It will fall down because reality is shared. So you have to understand this is a non-linear minimum, a non-linear, non-local minimum. If you're referring to a system of equation, So the mathematics says that's what the mathematics says. Without quantum physics, there's no quantum physics here. There's no superposition. There's no superposition. There is no entanglement, and there's no superposition, entanglement, and interference. There's no interference. Those three processes are eliminated because it's a classical system we're exploring. So how does it work mathematically? Mathematically, we have force F of t equals basically we're gonna try to parameterize F of t. F of t is a force. F of force equals m a mass m a mass times a of t, because the mass is a constant. So it's a at. F of t equals of m a t, a times t. So this just means a force at a time interval is equal to the mass times the acceleration at that time interval. Interval. Yeah. So yeah. So basically, if you have a complex number system, you have a real, imaginary, and a real component. In R3, basically, you have two realities. Let's say you have two fabric reality, two realities here. R3, R to the power of 3 represents the three-coordinate system of longitude, latitude, and altitude. And you have the same thing for a complex number system. You can always derive that equation. You can always derive from both systems the laws of physics, the mechanics of physics, because those are the mechanics that encode the reality. Basically, those are laws of physics. In one form or the other. So the translation is in the interaction, and to derive from any system, basically. Basically, if you place a ball on top of that apex and your movement was perfect, it was still, there was no change in inertia at any interval of time, that ball will never roll down that reality, but to roll down that reality because a rest, But if you start with interaction, a force interaction, it can't go forever because there is same concept applies, but the inverse, reverse converse, the intuition complication. You start it at unless you have the momentum carries through the pendulum and as it swings back and forth. So you get the system works on complex number. So one kind of proof is geospatial soundness of the geospatial nature of reality is that reality is shared. So so one reality the sheer objective of truths, the sheer the logic that the system arrives at mathematically in the kind of physics sense using physics. So I think I'm feeling this proof. So let me start with the definition. So we're gonna parameterize. So I'm gonna parameterize because see, I'm gonna try to integrate actually. So my first is to derive from both systems the laws of physics. But this is a big problem. So the laws of physics are the encoding of basically the codec. So the coding is the interaction itself. Because the runtime is what is gonna be running on. You know, the interaction, physically interaction, is the codec, is the code is going to be running on, and the codec is literally defined as the interval of how the system will operate mechanically at a mechanical level. Like if I take my hand and take a ball and place it at the tip of the apex, and I'm not careful to place it, and I place it perfectly. If the time runs out, if I say a timer and that time is measuring a period of time, uh, we can determine when that ball will roll down that hill because it's still jittering. So it's not to do that quantum physics, it's not to do with quantum physics or anything. It's just the principle of reality, it's just the reality. So because reality, uh, uh, you know, has to be shared. So you have we have so in this model we have let me start with the one you place the ball on, because that's what I'm familiar with. So you have one reality that has X, Y, Z. So one non-local, one local reality. Uh, as soon as you place that ball on top, let's call it R3 sub L local R3. R3 is a function of L start, where L start is the initial velocity. So if I make this the integration of well, basically only gravity is involved in this aspect. Only gravity. So only gravity. I forgot to mention that. So I keep saying no physics, no, just gravity. So one medium, one gravity. So only gravity. So you're gonna have local L min, local minimum is defined as uh uh, sine. I'm trying to make it 5 sine x. Basically, I'm trying to think of downwards action. So sine, cosine, basically so okay. So cosine theta, 5 cosine theta dx. So the ball is at inertia. So how would I derive? How would I encode this reality with this network? So how would I encode the math into the inertia? The inertia. I don't know, guys, but that's the idea I'm giving you. So we have 5 cosine. Cosine is the y. It rests at cosine, 5 cosine, which is a constant factor because the constant factor is affecting reality. So it has to go somewhere. So if I cosine dx, I have the equivalent of C3, C complex number C2 L mean equals complex number 5 minus 5i, integration of minus 5i. mean, I mean 5i means going up. So let's do minus 5. Minus 5 cosine, minus 5 cosine polar uh, a plus bi b I uh, dx. So you have a cosine a plus bi dx. Oh yeah, so this is a so basically after the sub, after I don't know the quantities or units of physics, but the idea is you have some system, you have a system encode that physical quantity. Break. You can't because it's shared interaction. How to read basically how to basically the encoding of the force is in the fabric. You have a reality. You see, if you can get when you decode it, you should get the fabric, the reality, the codec that was in the physics of codec. The laws of physics apply to a reality. So that's the objective reality you share, and you measure as true in a bipartite system. So if you have a complex number system and a physics of a real number system, reality shares the codec, the fabric of space-time. So these are all mathematical quantities because when you parameterize space, you get integration. No, wait, when you integrate a real system like RT, like if you convert a function of time to space, that space is a quantity, and they integrate over the quantities. So my next step was to take reality R3 and integrate over the time. When you integrate with time, you get the space equivalent, and the space are partial quantities of that reality, which we use to define to get the codec. And the codec refers to the actual physical interactions in space time at that interval in space, given time. Thank you for watching the video. This is my work. I feel thorough because I'm part man, but I don't believe myself anyway. I don't believe I can do anything anymore. Well, this is a big problem. And, without it's a reality problem. It's a non-local, local maximum, minimum. Basically, what the definitions of basically a graph. You have if you're tracing the function of a graph, you can have the non-local. No, that's what I mean. You have the terminology of the locality of it. You get terms like non-local. Basically, when you take an integral of a graph. You're talking about the apex, no, the top basically function at zero when it's a pointed curve, when it's a curvature, it's it's undefined. When it's a point, and a point when you have it, when you have a curve, a slope, you have concave up, concave down. But the term when you're mathematically analyzing a function, tracing a tangent line, that's what we call a tangent line, or performing the integral or under the curve at that time, which are referred to as maximum local and non-polar non maximum local maximum local minimum. Thank you for watching this video.